Have you ever built an AI agent that worked perfectly and then the next day it just didn't? Same input, different answers, and no way to tell why it failed? I've built somewhere around 300 agents at this point with Claude and Gemini, somewhere for real businesses through my agency, and I still build new ones every single week. So don't get me wrong, agents are amazing, this is the future, and I'm not telling you to stop building them. What I'm telling you is that there are places where agents break, a lot. And there are places where you should still build the classic automation. And I bet you it's way more places than you think. So here's what we're gonna get through today. First, the 4 shapes that these systems actually come in, because almost every argument online happens between people using the same 2 words, AI agents, for 4 different things. Then we're gonna go through where agents break, and the math behind why. And then we're gonna ask one simple question: which one should I build and when? Okay, let's start with the 4 shapes, because everything after this depends on it. Okay, so shape 1 is a plain automation. It looks just like this. A simple system with multiple steps. You decide what's the trigger, it could be a scheduler, a webhook, a manual trigger. It cannot decide anything, and that's the point. It will do this exact thing 10,000 times and get the same result 10,000 times. There's no intelligence anywhere in it. And an automation is an anything flow, but it's not just that. It can be a simple software product, like a small app, and you can vibe code it with Claude or any other AI tool. So both of these are automations. Okay, now shape 2, the agent. This one is what you see in Claude Code, the guy you talk to. So you talk to a model, and then that model has access to different tools, and it decides the path. It decides what order to go in, and basically what to do with these tools that it has access to. Now shape 3, the automation that uses AI. This is what you've seen all over YouTube a few months ago when people were all over N8N. Don't get me wrong, it's still a great tool, you should still use it for some specific use cases. It looks just like a simple automation, but now it has a step that's AI. Most of it is something you set up before, and then you have an AI that answers a specific question or does a specific task. Let's take an example. So if you want to classify emails, there's no deterministic way in which you can do so. So you need an AI agent to tell you whether this is a question or a complaint or something like that. Now this is still an automation. Everything is an automation basically, we're just defining how you can build them now. Now this is still part of shape 3. You can have this automation system with more steps, but then you have more AI calls. So you have the trigger, then an AI step, then a step that's built with software, then another AI, then another software step, and then another AI. Okay? This is still an automation. Let me give you an example again. The trigger could be receiving an email, then you can classify it, then through software you do some math, then you summarize the email together with that math that the software built, but then you didn't need another software step to create the exact design that you want, which is a standard, so you don't need a probabilistic system here, and then you use another AI to create a draft. This is still not an agent, because these can't make decisions. They are just used for a specific thing. So here you still know exactly what happens and in what order. There's one more thing here. One step can be a whole agent. So you can have like a trigger, then you have an agent, and this agent has access to different tools, and then you have more software steps. It can be placed anywhere in the pipeline. Now the difference between an AI agent and just an AI doing something is that these AI agents can make decisions. It can choose where to go. It works in a loop, and it decides itself when it has the result that the user asked for. So it keeps working until it feels like it got the desired output. Now shape 4 is the agent that runs code. Okay, this is another way to go about it. So you have an agent, and then you have code blocks. This could be like little Python scripts or stuff that are deterministic. You get the same result every time you run it, except a few bugs. Now this agent here is smarter just because it has a few deterministic steps in his system. So he's not responsible for everything, he's responsible just for orchestrating the whole thing. So when it needs to calculate a total, you've seen it all over the internet how it makes mistakes. It doesn't need to calculate it itself, it can use a Python script to do so. So the agent keeps the thing that it's genuinely good at, which is deciding what to do and interpreting messy output, and everything that has to be exact stays in the code that runs the same every single time. So these were the 4 shapes. For shape 1, you design the path, and this is for the automation. For the agent, the model designed the path. For the automation that uses AI, you design the path, but AI does the jobs inside it. And then for the agent that uses scripts, the model designs the path, scripts do the exact work. Okay, and the real question is not which one is better, because they all work, it's which one fits the job in front of you. And that's what I want to help you understand throughout this video. Now, I want to show you why I keep pushing work out of the model and into code. And there are 3 reasons, and the first one is just arithmetic. So, classic code is the same every time, except a few bugs. This is what we call a deterministic system. So you have the same input and the same output forever. That's why you can test it, and it's why when it breaks, you can reproduce the bug and actually fix it. A language model is a bit different every time. This is what we call a probabilistic system. The same input can take a different path each time. And it doesn't do this because it's broken, it's because this is how it works. It predicts the most likely next thing, and most likely is not always. Say every step your agent takes is 95% reliable. That's a good agent. Now, say the workflow has 20 steps. 0.95 to the power of 20 is 36%. Your 95% agent completes the whole job correctly like 1 in 3 times. And that's a compounding error. Every probabilistic step multiplies against every other one. So this right here is your agent with I don't know how many steps, and here's the fix, which is the law in the rest of this video. You basically add deterministic steps inside your agent, or you build a deterministic system which uses agents, and these steps have an error rate of basically 0. I mean, it's never 0 because you have bugs and you have uptime, but it's close to that. So 20 probabilistic steps give you 36%. Move 16 of them into code, keep 4 where judgment is actually needed, and you are at 81%. You have to reproduce the same work and use the same intelligence in the places that need intelligence. And it's more than double their reliability. And this is basically architecture. Notice that this doesn't tell you exactly what shape to build. It just says fewer probabilistic steps wherever they live. There's a second half to this, and it's worse. When code breaks, it crashes, so you know. You see an error. But when an agent breaks, it finishes. It hands you something that looks completely normal. But if in one of the steps it made a mistake, then every step built on that mistake and the output is wrong. And you're gonna find that hours later from a customer. So the failure you can't see is the most dangerous one. Now the second place where they break, and this applies to wherever you are, but it's a bit different depending on the country you reside in, or it also applies if you're working with clients that reside there. For Europe it's usually worse than for any other country. Now real inboxes are full of personal data. So it's names, phone numbers, addresses, bank details, sometimes even medical information. If your system reads that email and passes it to a model, that data has left your company and goes to a third party. In Europe it's crossed your processing boundary, and GDPR has a lot to say about it. In the US there's no single federal law, but it's grown to around 20 states with comprehensive privacy laws. And by the way guys, this is not legal advice, but this is something you have to take into consideration when you build your solutions. And if you touch something health related in the US, I mean in Europe as well, but in US it's under HIPAA, any vendor handling that data under your behalf needs a signed agreement in the first place. So that means that you're not allowed to use regular ChatGPT, you're not allowed to use regular Claude or a personal account. Their own terms tell you not to send it, but you're allowed with the signed agreement. Now I'm not talking just about medical data, I'm also talking about GDPR and PII. The fix is small and it goes up front, you just need to cover it up. Then you send it to an AI covered, and then you put it back. So you take the data, you encrypt it, you send it as placeholders to the AI, and then with another code block you put it back. So the real values go around the model. You never send that data to the third party. And if you use a simple AI agent, then it's very, very risky. One detail matters a lot here. This has to be plain code. It shouldn't be another AI. If you got the third party with another third party, you've just moved the problem. And there's one more layer to this, which is where the rules are heading everywhere. For AI making important decisions, roughly 2 things are asked for. Log what the system does and keep those logs. And the second one is to have a person say yes before he does anything that matters. So you need to add a manual approval step. For Europe, you already have to do this, and some states in the US already push towards this. I feel like it's just because if your company does something wrong, you won't be able to blame a probabilistic system that makes a lot of mistakes. So look at this too. A log is deterministic. It's a piece of code. An approval gate is an if statement. The regulation is telling you the same thing that the math did. The model can't be the whole system. Now the third place where it breaks, and I'll go fast with this one because I already touched it a bit before. Anything that has to be exactly right every time. invoice total, tax, payroll. Now, models are good at arithmetic, but good isn't the standard here. If they can make mistakes, you can't use them. You could with an approval step, but then a human would have to go through the math again. So what's the point? The split is clean. The model should be used to read the messy emails and pull out the line items, because that's a judgment task. Then it should hand these numbers to the code, and the code should do the math. So the model extracts and the code calculates. So that's the why, 3 reasons to push the work out of the model. Now the actual question is, which shape do you build? One question, do you know the sequence of the steps before you start? If you know the sequence, the automation owns the path, and AI does jobs inside it. It's shape tree. Every invoice gets processed the same way, every Monday report gets built the same way, every new sign up gets the same 5 things done to it. The steps don't change based on what comes in, only the content changes. And that's most business processes. That's the truth, and is the reason this video has the title it has. Someone looks at their invoice process, hears the word agent everywhere, and builds an autonomous system that decides how to handle each invoice. But every invoice should get handled the same way. There was never a decision to make. You built a probabilistic system to do a deterministic job, and now you own all the 3 problems that I've just shown you for absolutely no benefit. In this shape, the model is a specialist you call in for one thing. Read this messy PDF and pull out the lines. Write this paragraph in a human tone. Classify this. Everything around it should be code, so everything around it is reliable, cheap, and inspectable. Now, if you don't know the steps before you start, if the sequence genuinely changes case by case, you cannot write it down in advance. And this is shape 4. The agent owns the path, but you should still have code for deterministic stuff. Customer support is the honest example here. One message is a refund request, the next is a technical problem, and the next is somebody who's confused about a process that you don't have defined yet. You can't draw the flowchart just because there are hundreds of branches and half of them you haven't defined the process for. So the agent decides, and every exact thing it needs gets handed to it as a script. It doesn't calculate a refund, it calls the refund script. Or it could be an MCP. It doesn't guess the stock, it calls the stock MCP. The agent does the deciding, the scripts do the doing. And notice that the 2 shapes end up looking more similar than you'd think. Both of them strip personal data before the model sees it. Both of them put exact work into code. Both of them put a person behind anything important. The only difference is who's holding the map. And here's how I'd actually approach any new build. Start at the bottom and only climb when something forces you to. So can plain code do it? Then do that and you're done. Does one step need judgment? Add an AI step and keep the rest as code. Does the whole path genuinely change per case? Fine, now you've earned an agent. If you just want to test stuff out, then you can start with an agent because it's faster to build. But if you're building for customers, for real businesses with real data, then you have to start at the bottom. And by the way, you don't need to know how to code. You can just plan this stuff out with Claude or with any other AI tool. Okay, now you might be thinking, this is one guy with opinions. Fair, but let me show you who else says it. This is Anthropic's own engineering guide. And this is called Building Effective Agents. Now, this is a passage I like a lot. When building applications with LLMs, we recommend finding the simplest solution possible and only increasing complexity when needed. This might mean not building agentic systems at all. Agentic systems often trade latency and cost for better task performance. And you should consider when this trade-off makes sense. The company whose models power half the internet right now is telling you that maybe you shouldn't build the agent. Now, this is something that I haven't mentioned throughout the video, but there are cases where you can still build simple agents. For example, I use a few for my work. When I build my thumbnails, I don't need them to be perfect. I can keep retrying. I don't need the same exact result every single time. When I create presentations for the videos, just like the one you've just seen, I can just reiterate. This is not a process that I have to get the same result every single time. When I make offers for customers, I use some basic AI agents and simple ones. So there is stuff in your work that could be automated by AI agents, definitely. Where you can just work with the chat box and you can keep refining until you get the result you want. But make sure there's not personal data there about your customers. So I'm not telling you to stop building AI agents, I'm telling you to stop making the agent the whole system. Let the agent decide only what needs deciding. You can let the code do everything else. And of course you can vibe code it. Put a human behind everything that matters, and that's how you get something that works the same way on Tuesday as it did on Monday. Now, this is what this channel is about, building automations and agents And if you want to learn how to use Claude Code, then check out this video right here. I appreciate you making it until the end, and I'll see you in the next one.